Hey, this is the video tutorial to go with the first lesson of SOL Remediation. If you want to pause the video, you can look at the 18 topics we're going to cover in today's lesson. Which graph is represented by y is less than or equal to 2x plus 1? So for questions like this, we should just go ahead and type it in. I just put that as a little reminder to myself. Now you can type in the less than and the equal to, but what you're really better to do is just click on the Desmos Calculator and then you can see exactly which one that you want. And then we can just look at the picture. So a few things we should be looking at here is we should certainly be focusing if it's a solid or a dotted line. We should also be looking at where does it cross the y-axis and where does it cross the x-axis and which side is actually shaded. So let's go back and see which one's the closest. I can see 1 and 2 is totally the wrong direction. I can see 3 is actually, looks like apparently shaded totally the wrong side as well. So from process of elimination, I can see that it's 4, but see the intercepts. The y is clearly 1, and the x-intercept is between 0 and -1, which you can clearly see on this picture here as well. Quadratics. Find all the solutions to y equals 9x squared minus 25. So for squared, easiest just to push the squared button here and then type in the rest of the question. So it says, look at where it crosses the x-axis and change these decimals to fractions if necessary. So 1.667 and negative 1.667. Now, I deliberately picked one that's slightly more complicated. So if this one comes up, you'll be aware what to do. If you hit the fraction button straight away, it will actually change it into a fraction, but that's not the right answer. What really happened here is Desmos rounded the answer to 3 decimal places. So the 6, with the next number being greater than 5, it rounded up. That's why I put 1.667. So what we have to do is we actually have to keep going with these 6s here. Notice how that fraction button disappeared on the left. Keep going. I have to press it for a little while, but it will actually give the correct answer, which is 5/3. And same with the other one, actually. It's really 1.6666. And if we click the fraction to decimal button, we can see negative 5/3. So sometimes it'll ask for a decimal, sometimes it'll ask for a fraction, and that's one way you can do it. Sometimes if it's not clear, you can also type in the answer. So for example, if you had 4/7, you could type it in and it will actually tell you what it is as a decimal, and then you could compare that decimal to the decimal that you see here in Desmos as well. Also, in relation to factoring, which is basically the same type of question, if you asked to factor 9x squared minus 25, you would just type it in, you would look at those, and then you would figure out what the actual decimals are, the fractions are, and then you could actually take the answer from there. So you would do the opposite. So we found out that it was 5/3. So the opposite 5/3 is negative 5/3. And for the other one, it was negative 5/3. And the opposite of that is positive 5/3. Oops. And then these bottom numbers actually just move to the front. So you'd have 3x minus 5 and 3x plus 5. Now, that can be a little complicated. So particularly if we have multiple choice answers, what we should do is we should type in the question and then type in each answer choice and see if it gives us the same picture. If it gives us the same picture, then it's possible that this is the answer. So it might be answer B, but I'm going to keep going. Definitely not answer C, that's for sure. Now, notice that these two actually both gave us the same answer. So we're now going to try and figure out which is the correct one. So I know for factoring, you're not allowed to have any fractions. So for that reason, I know that's not the correct answer. And therefore, I can actually select this answer here. Always look to see on your factors, is there a hidden factor inside? So if, for example, 3x plus 6 was one of the answers, I know this is wrong straight away because both of these would divide by 3. And for that reason, I know that it's not fully factored. So that's a good little way of checking some of those answers. Also, at the same time, let's not forget about x-intercepts, zeros, roots, and solutions. They all mean the same thing. So you're just clicking on the x-intercepts, whichever word they give you. And on a question like this, you would literally just click on the picture and you could write down the answers. So for this one, if it asks you to write what the answers are, it would be negative 3 and 1, but they might just ask you to draw on the picture. If they ask you for factors, then we just do the opposites. So where it says negative 3, you would have x plus 3. And where it says 1, you would have x minus 1. So you just change the signs if you're not sure. If you want to find the convert from the intercepts, into the factors. That's the end of quadratics. Radicals. We did this one fairly recently towards the end, so this is really just a recap. Find the square, simplify the square root of 675. You type in the question to get a decimal, and then this is where we're using the table. So you would click on plus, you click on table, and then you change y1 to the number inside the square root divided by x1 squared. And then you would start from this number here, 25. And it says keep counting down until you get two whole numbers. So if I type in 24, press enter, and actually I didn't even type in 23. It knows exactly what I'm going to do right now. And we just keep going until we see those two whole numbers. Sometimes it takes longer than others, but there we go. 15 and 3. So that actually means that my answer, if I just get rid of this here, is 15 square root of 3. So notice the second number we put back in the square root. And the reason I wanted to type this in was, can you see here the decimals are also the same? So that tells you that these two expressions are also the same. But it is really important that you stop the first time you get two whole numbers, because you could continue downwards actually and possibly find other answers that also have two whole numbers, but they would possibly be the wrong answer. So you always want to stop at that first time that you see two whole numbers. Now, extension questions from this, they could ask you to work something out like this with the letters. So just focus on the numbers, work out that it was 15 and 3. And then from here, you could actually figure out pretty easily that it would be answer C, because it's the only one that has a 15 and a 3 here. Actually, if you did carry on down with Desmos, 5 and 27, I believe, would also be an answer that works, but not in simplest form, because the square root of 27 simplifies. The reason x to the 5 is correct, the rule for exponents is that you divide the exponent by 2. So 10 divided by 2 would be 5. If you have more complicated questions where you have, for example, numbers in front of the square root, focus on the square root first, work out what that is, as in 15 square root of 3, and then just times the answer by 2, and then just combine like terms. So 2 times 15 is 30. And just remember, for questions like this, you can use decimal checks as well. So type in the question, type in what you think is the answer, check all the answers though, just to make sure there isn't multiple ones. If you have multiple answers the same, pick the one that has the smallest square root to make sure you get the correct answer. Functions, this was really our last unit. This was our last one this year. So which is not a function? So make sure you understand the words carefully and make sure you are answering the correct question. So this one, we're looking for different x values. So for mappings, you're just looking how many lines come from each one. So there's just one from this one, just one, just one, just one. We're not worried that 2 go to a y value. We're just looking at the x values. And if you look on graph C here, you can clearly see that there are 2 lines coming from 1. And for that reason, I would select C. C is not a function because there's a repeat x value there. Domain and range. So if we look specifically at this one, domain, you're literally just looking at the x values and you're putting them into order. So 1, 2, 3. And the range, it's not just 1, 2, 3, 4, because not all of these have arrows going towards them. So it would just be 1 and 4. Now, technically, there's 2 numbers going to the 1, but you don't have repeats when we do domain and range. So just 1 and 4 would be your answer. Try to figure out which graph goes with which one. And if you're not sure, you could just type them in on Desmos. Type in each picture and just make sure you match up which one is which. Some of the words we used were hoy and vux earlier, but I wouldn't even recommend using that. I would literally just go ahead and type in each picture and check exactly which one it looks like. So if I was to type in y equals 4, for example, you can see it's the horizontal line. So I know clearly that graph A is 1. And then from here, I've already narrowed it down to 2. And I know the next one is either C or D. So I could probably just type in C or D. So let's have a look at y equals 4x. And you can see this is a line that has positive slope. So that's that one there, I believe. Yep. So actually for this one then, it would be 2C. And therefore I can probably check the other ones as well just to make sure. 3b, if you type in x equals 4, you do get this graph here. And for 4d, you would get one with negative slope. So those words hoy and vux sometimes help us as well. So hoy, when you see the horizontal line, you know that the slope is 0. And you know that the equation was y equals a number. That was why it was this one. And for the vertical line, we use the word vux. Oops. Slope is undefined. And it's x equals a number, which was in this case x equals 4. Simplifying exponents. So just a quick reminder, when you multiply, you add exponents, and when you divide, you subtract exponents. And we're asked to work out this expression here. Now, ideally, what I'd be trying to do is I would be trying to use my power to a power rule on this 3x squared. So when I do my 3x squared, I have to do the 3 squared, and I also have to do the x squared. And this is not going to be very neat, so I apologize. So we got 4xy. And then the others you just work out using your Desmos calculator. So 3 times 3, or 3 squared, is 9. And x squared is literally just x squared. There's nothing we can do with that. And then as we multiply, 4 times 9 is 36. X times x squared, you'd add the exponents. So if there's no exponent, remember there's a 1. So 1 add 2 is 3. And then you just have a y at the end. And we can see from that one then, this would be answer choice D. Now, there is a way of doing this on the Desmos calculator as well, if we want to. What we can do is we can actually go ahead and we can type in the question here, the 4xy. It's a little time consuming. 4xy, and then it says 3x squared. Now, there is a warning because we actually typed in a y here, and it doesn't like y's. So wherever you see a y, you can just go back and type in an x. So I'm typing in the same question. Basically, I'm just making all the variables x. And then what I'm going to do is I'm going to check each answer, and I'm going to try and match it to the picture that you see here. So let me quickly just take a look at, oops, what was the first answer? So the first answer was 12x, whoops, was 12x squared y. So 12x squared y. Remember, wherever it says y, I'm typing in x. And hopefully you can see pretty clear that's definitely the wrong answer. Now, as we know the correct answer is D, I'm going to skip straight to what answer D was, 36x cubed y. And then you can actually look to see what actually happens. So there's my 36x cubed y, but once again, you can't type in y, you can type in x. And look, you can see that this picture is exactly the same. So that's a really clever way of finding out the correct answer without having to do any algebra. You can just look to see which graph actually matches. Oh, here we go. I actually have them all typed in here so you could actually see. So there was answer choice A, which we saw was wrong. There was answer choice B. There was answer choice C. So you can see they're all wrong, but answer choice 3 is the correct answer. I was a little confused because I knew I'd created that screen. That was just for doing the little Desmos calculations. Now, questions with divide, you just split it up into 2 questions. So you take the first term divided by the denominator and the second term divided by the denominator. Numbers first, so 12 divided by 4 is 3. And then we subtract the exponents for division. So 6 take away 2 would give me 4. For the numbers, 4 divided by 4 is 1. Writing 4 for some reason, and 1. And actually, when we have the same thing on top and bottom, we can just cancel them out like this, which is really helpful. Now, I don't want to do that with a 4 and 4, because I might think that it's 0, and I might actually pick out the answer 3x to the 4 if that was one of the options. So numbers divide, but certainly if you have the same exponents, I would cancel those out. And actually, you can see straight away then, this would be answer choice 1. Now, the other way to do that is you can type in the question. This only has one variable. So you can type in the question and each answer choice, and there you go, boom. You can see answer A is the correct one straight away. Whereas if you check B, different picture, C, different picture, D, different picture as well. So that's a really useful way of checking some of those questions. Properties, we probably either know or we do not know. So let's have a look at the answer and then we can see exactly which is which. So the thing about this is it's the same order, 2, 3, 4, 2, 3, 4. But the thing that's different is the parentheses. So the associative rule is when it's the same rule, but you're grouping things in a different order. So the parentheses are at the start, and on this one, they're at the end. Commutative is when you change the order of the terms around. So instead of going 2, 3, 4, it might go 3, 2, 4, or something similar to that one. Symmetric is when you have something on the left and the right, and you switch them over. So it could equal 1, and then you could say 1 equals those same things. And reflexive is when you have exactly the same thing on the left and the right-hand side. Hopefully not too many of those questions, but if you can know them, it can make a little bit of a difference. Perimeter. Now, this one can certainly be a problem because we've got a vocabulary word here. So perimeter means that you're going to add together all the sides on the shape. However, they only labeled 2 of the sides. So we have to use some common sense. And we know that this side at the top, which I'm just going to put a little star here, we know clearly that's going to be the same as the side that's on the bottom here. And I'll just put a little triangle here for something. So on the right-hand side, we also know that this side here would also be 3x plus 7. And we know this is 2x plus 5. And then we can just go ahead and we can add all the terms together. So if you write them all out, you can like this. Here we go. So this will make this a little easier for us to do. So you write out each of the terms, and then if you're doing this by hand, you would say 2x plus 3x is 5x, plus 2x is 7x, plus 3x is 10x. And I can already see the answer is clearly going to be 10x plus 24 because it's the only answer that has 10x in it. 5 add 7 is 12. 5 add 7 is also 12, and 12 add 12 is 24. So it definitely is this answer. But once I've actually got to this stage here, you can actually check each answer and see if it gives you the same picture. Don't even see that one, so it's definitely not that one. Yep. And you can see clearly that's not the right one. So just be careful when you're doing these questions that you remember to label all 4 of the sides and not just 2 of the sides. So perimeter is just where you're going to add all the sides together. And you can see it probably better here. As it's all written out here, you can just focus on the blue terms, which are the x's, and you can focus on the black terms, which are just the constant terms, and then you can add them together easily. Subtraction, we can just do 3x take away 2x is 1x, or x, and 7 take away 5 is 2, as in positive 2, and that would certainly give us the right answer. If we're not sure, we can definitely do that same trick. Type in the question, type in each answer choice, find the one that gives you the same picture. There you go, it's this one here. And just check all the other ones just to make sure. No, I don't even see that one. There we go. And you can zoom out actually if you need to. I think that one was just a little bit higher. There you go. But you can see clearly that's the wrong picture. So rearranging equations, we looked at slope-intercept form and standard form when we looked at our graphing unit. And switching between the two, we can use that very clever trick of just typing in the question and then looking at the answer for each one. And just check, does it actually give you the same picture? There we go. It looks like we already found it. It looks like the second one. Go ahead and check all of them, though, just to make sure that there isn't a problem with this. But you can see quite clearly for this one that it would be that answer choice B. In reverse, you might be asked to write something in standard form where you have the x and y on the same side. So we have a few choices here. That one looks like it's the same. I'm going to keep going though, just to make sure. And the last one, so we actually have 2 that are the same here. This one and this one are both the same as this. And then this is where a little bit of knowledge comes in. So for something in standard form, you're not allowed any fractions. So that's not a problem for this. But the leading term must be positive. So the x term must be positive. And for that reason, we're going to ignore answer choice A. That's also the reason why, if possible, try and check answers D, C, B, A in reverse. So the first answer that you come to is probably going to be the correct answer. They do like to put trick answers at the start, things that look good, but turn out not to be good. So by starting from D and working upwards, you can often avoid those answers. Systems, really easy to do. You type in the equations and you just look where they cross, and you literally just click on the dot and it will show you exactly where they intersect. So it could be a coordinate, or they could just say x equals a number and y equals a number. If you see parallel lines, that would be no solution. And if they're identical lines, that would be infinite solutions. So normally if you only see one, what you kind of want to do is you want to switch off one of the lines, switch it back on again, see if it draws over the top of the original line, and that'll tell you if it's the same line. So for this one here, if you do only see one line, you can switch it off. But this one here, you can see these are exactly the same line. And for that reason, this one would be an example of infinite solutions. Whereas this time when you type them in, you can clearly see these are parallel lines. So these do not cross. So this would be an example for no solutions. Word problems can be a little tricky, but we'll do the best that we can. So a bag of 20 coins contains nickels and quarters. So the number of nickels plus the number of quarters equals 20. And then it says it's worth $3.60. So think about what each of these is. So a nickel is 5 cents. So if we wrote it in dollar terms, we could certainly put 0.05. And for the quarter, we know that's 25 cents. So 0.25Q. And what does it equal? Well, it says $3.60. So 3.60. And then we could type those in. Now, I actually did it slightly differently because there's a couple of different ways. First of all, it won't let you type in N for nickels, so you might as well change it straight away. So I said let X equal the number of nickels and Y the number of quarters. Instead of putting out 0.05, I just put 5 cents. 25, I put 25 cents. Now, if I do that, though, I can't put 3.60 because if I do that, that means 3 cents and 0.60, whatever that means. So obviously, $1 is 100 cents. So $3 would be 300 cents. And then $3.60 would be 360. Now, we don't see anything straight away. So sometimes we have to zoom out on questions like this until we can find that intersection. 7 and 13. So this question asked about nickels. So the first number was nickels. So for this one, the number of nickels would be 7. Notice 13 was an answer, though. But we had nickels first. So that first number that we see would be the correct answer. Slope. Find the slope between 3, 7 and 5, -1. Now, you could just type in these two coordinates and it would plot them for you. I went ahead and typed in this y1 still at mx1 plus b, and it actually joins it up and connects the dots for you. And the reason that's useful is right at the bottom here, it says m equals 4. That tells you the slope of the line. That means the slope of the line for this line, -4, is -4. And if it asks you for the equation, then don't forget, after you've got the slope, you would put an x next to it. And then that other number is just the second number that you can see here, the b. If you want to count out the squares, you can. It goes down 1, 2, 3, 4, and then across 1. And -4 divided by 1 is also -4. Or if you count all the way down, -8, and then 2 across, and -8 divided by 2 is also -4. So a couple of different ways that you can find those types of answers. Horizontal and vertical lines are very specific cases. So what is the slope? So there's those words from earlier again. So this is a horizontal line. So I'm thinking of the word hoy, and I can see that the slope is 0. What is the equation? Well, we've got the y part here, and it just equals the number that it passes through on the y-axis. So y equals -4. Of course, you could type each of these into Desmos and take a look at the picture and make sure that you get the correct picture. So if we check, that one's no good. That one's no good. That one's the same picture. That one's good. And that clearly doesn't look anything like it either. What is the equation of a horizontal line passing through 2, -4? So horizontal lines, once again, just think about the word that we're using. So this would be hoy, because it starts with the H for horizontal. And then just look for what is the y coordinate here. So 2 is the x coordinate, and -4 is the y coordinate. So there's your answer. Y equals -4. And for the vertical line, you'd use VUX, because that begins with the V. And look this time for the x value, which is the first one, which is 2. If you were given multiple choice answers, something like this, you could possibly just click on each one as well. The first one said horizontal, so I know that's not good. Might have to zoom out to see some more of these. Here we go, that's better. No, clearly not that one. That one's horizontal, but it does not go through the point 2, -4. Notice I typed that so I could check. But that last one, you could see that it is y equals -4. So you can use Desmos as well to help you if you're not sure. Using the Desmos calculator for finding equations of lines. So it says find the line of best fit. Save the time, I already typed this one in. Now, I actually typed in both equations and said, hey, make a decision. Which one is it? Is it this one or is it this one? Now, I'm going to switch that one off for a second, and then I'm going to put this one back. So this one looks pretty good. You can see this goes through every single point here. Now, this one will also go through every single point, which is why you need to focus on, is it actually a straight line or is it curved? So as this is a straight line, I'm definitely going to pick this one out here. So the numbers 3 and 5 tell me the equation is 3x plus 5. And when it says what is the value when x equals 10, you can just type in the number and you can just go ahead and look where does it actually cross. And then you can pick out that number. So 35 would be the answer for this one. Variation, another one we did right at the end. It doesn't tell us which type of variation, so we got to figure that out, and then we got to figure out the rule. So 5 burgers, $20, 3 burgers, $12. So I would recommend actually typing in those two coordinates, and I would always recommend typing in 0, 0 as well. And the reason I would recommend that is if you can see all the points lying on the line, then you can say straight away this is direct variation. And that looks pretty convincing. That looks like a straight line to me. Remember, if it's the other type of variation, it will actually be a curved graph. So this is clearly a straight line graph. And then we can try and figure out which equation is it. So is it this one here? Well, clearly, because it goes through all the points. Or is it this one here? Definitely not. So you can use the types of equation. Direct variation is y equals kx. And inverse variation is y equals k over x. So you can easily figure out which one is the correct one. Solving basic equations. Kind of looked at this earlier in a slightly different way. You can just type in the equation, and then you just look for that x-intercept. 3.5, there you go. If you want it as a fraction, just go ahead and press that fraction to decimal button, and it'll do it for you. If you have it within an equality, just look which side is shaded, and then you can pick out your answer from that. And it's shaded to the right, so just make sure you pick that same inequality that's pointing to the right. So the answer would be x is greater than or equal to 7 over 2. If we have ones where they're special cases and they turn out not to work, then, if I graph this, let me just zoom out just to see. Notice how I don't see this at all. So I'm going to split this question up into two, the left-hand side and the right-hand side, and I graph them separately. If they don't cross, then you just put no solution. If it turns out to be the same line, it's infinite solutions. So if you don't see the picture, it tells you straight away that it's one of those special cases, and you can figure out which one it is. Which one is direct variation? Well, we just talked about this. Straight line goes through 0, 0. So it looks like to me, answer choice A doesn't go through 0, 0, doesn't go through 0, 0, doesn't go through 0, 0. Try and plot 3 points to make a direct variation graph. So this is one way you have to draw on the actual picture. So the most obvious one is we know 0, 0 must be one of these pictures, one of these points. And then to find the other ones, we just do some counting. How do we get from one dot to the other dot? So I'm going to go from here to here. I would go 2 to the left and then 3 up. And then if we repeat that pattern, 2 to the left and 3 up, there's my next point. One more time, 2 to the left, 3 up. Notice I have 3 points, but more importantly, notice that they're all on a straight line and it goes through 0, 0. That's how I make sure that I get my direct variation graph. There were other points that you could have picked on the line, but as long as you pick 3 extra ones, then you're okay. Distributing, nothing too complicated. Remember, you multiply the number at the start by each of the terms in the middle here. So 8 times 2x, 8 times -3. We do numbers first. 8 times 2 is 16 with an x. 8 times 3, 24. And this could easily be a question where they ask you to find the area of a rectangle. So we did perimeter earlier where you add all the sides together. Area, you just multiply the 2 sides together and you would write the question like this. Functions again. So which of these are functions? So that might mean that there's more than one correct answer. We're looking for different x values. So as I'm looking here, I see 2, 3, 4, and 5. They're clearly different, so that's good. On this one here, I see 2. Well, already I've seen a repeat x value here, so I know this one is wrong. For this one here, I see 2, 3, 4, 5. Once again, they're all different, so I'll take it. Not interested that all the y values are the same. They're hoping that's what you're going to pick, but that's not interesting. We're only interested in the different x values. And for the last one, 2, 3, 4, 3. Whoops, we have 2 3s, so that one would not be good. And they're the 2 that you would select, A and C. And it's just a little easier to see if I just go back to that picture. So the ones with blue are the repeat numbers. There you go. You can see much clearer now that that is a repeat, and therefore it wouldn't count. Is this the same question? I think that's the same question. Yep. FOIL. You can definitely use a grid for these questions where you type the first one across the top and the bottom one down the side, and then do the multiplying. Numbers first. 3 times 2 is 6. X times x is x squared. And remember, you often get x squared in this top corner here. 3 times negative 3 is negative 9 with an x. Negative 2 times 2 is negative 4 with an x. And negative 2 times negative 3 is 6. Now, notice some of these answers don't even have a 6x squared in, so I know it's between A and B already. Oh, sorry, B and C. And then for these middle terms, these are the ones where we're going to add. So we're finished with the multiplication side. We're just adding these now. Now, they're hoping you're going to do negative 4 times negative 9, because that gives you positive 36, but that's not what we're doing. Negative 4 and negative 9 is negative 13, and then the 6 in the corner is your positive 6. Any adding multiplication you're not sure of, go ahead, just use Desmos. That will definitely check those numbers for you. And possibly even better, you can, of course, once again, type in the question, type in each answer, and check, is the picture the same? As soon as we find the one that's the same, looks like C to me, then we know that's the answer, and we did find it was C earlier. And just to be aware also for this type of question, they could also give you this as an area question as well. They could label the two sides with variables like this, and then ask you what's the area. So you need to know that this is the same as this question. That covers 18 topics in lesson 1. When we get to lesson 2 and lesson 3, we'll repeat those same 18 topics so you'll get used to them. We'll make the difficulty level just slightly more difficult each time, just so you can practice and get a little bit better in case we have those more difficult questions.